Next, Gibbs free energy. Gibbs free energy, it is represented with the G. The change in Gibbs free energy is represented with the del G. Now, what is the significance of this Gibbs free energy? Now, if you observe the thermodynamic property enthalpy, the first law of thermodynamics, it has introduced the enthalpy or enthalpy change to explain the spontaneity of the various changes. But the first law of thermodynamics could not able to explain all spontaneous process with the help of this enthalpy change. Therefore, to explain the spontaneity of the changes whose spontaneity cannot be explained through enthalpy change, can be explained through entropy change. That means second law of thermodynamics, it has introduced one more thermodynamic property called entropy change to explain the spontaneity of the changes whose spontaneity cannot be explained through enthalpy. Then the second law of thermodynamics also has not able to explain the spontaneity of the various changes that are taking place in the nature. Therefore, to explain the spontaneity of the changes whose spontaneity cannot be explained either through enthalpy and entropy change, can be explained through free energy change. Therefore, this free energy change has been introduced only to explain the spontaneity of the certain complex changes whose spontaneity cannot be explained through either enthalpy or through entropy change. Therefore, the significance of this free energy change is it is only to explain spontaneity of those changes whose spontaneity has not been able to studied by enthalpy or entropy change. Therefore, Gibbs, he introduced this free energy. This is another thermodynamic property. This free energy, it is also an extensive property. It is an extensive property. Next, like enthalpy and like entropy change, it is a state variable. It is a state variable. Next, according to Gibbs, what is the simplest meaning of the free energy change? Say for example, we have one particular system. Let us say the total energy present inside the system can be represented with the H. H means enthalpy. So, we will usually represent the total energy of the system in the form of the enthalpy. Next, this is the total energy present inside the system. Whenever if any system try to do some work, when it try to do some work, it will always try to convert that stored energy into useful form. While the stored energy try to get converted into useful form, in this transition state, always some amount of the stored energy will get wasted. The energy that get wasted during the conversion of stored form of energy into useful form is represented with the Ts. This is called energy that is getting wasted during the conversion of stored form into useful form. Then this is the total energy that is getting wasted. Therefore, stored energy or total energy minus energy that is being wasted is equal to energy that is available for any useful purpose. Therefore, according to Gibbs free energy, this G is equal to H minus Ts. H represents the total energy present inside the system. Ts represents the energy that is getting wasted during the conversion of stored form of energy into useful form. Therefore, this is the G represents the useful form of energy that participates in the useful work. Next, the change in free energy. The change in free energy is represented as del G is equal to change in enthalpy minus this is a temperature. If you assume temperature as constant, change in entropy. So, therefore, the change in free energy is equal to change in enthalpy minus at constant temperature TdS. Next, so therefore, just briefly discuss about the significance of this change in enthalpy, change in entropy at various conditions. See, we have H is equal to U plus PV. U represents the internal energy, P represents the pressure of the ideal gas, V represents the volume of the gas. Therefore, G is equal to U plus PV minus Ts. U plus PV minus Ts. Therefore, change in free energy is equal to del U plus P dV plus V dP minus T ds minus S dt. Minus S dt. Next, according to first law of thermodynamics. According to first law of thermodynamics, dou Q is equal to du plus P dV. Plus P dV. Therefore, du is equal to dou Q minus P dV. Next, we have one more formula about the entropy. This entropy change is equal to dq upon T. Therefore, dq is equal to T ds. T ds. Therefore, du is equal to, in place of dq we can substitute T ds. T ds minus P dV. Therefore, free energy change del G is equal to du. Du means T ds minus P dV. Next, plus P dV plus V dP minus T ds minus S dt. Minus S dt. Therefore, plus T ds minus T ds minus P dV plus P dV. Therefore, del G is equal to V dP minus S dt. Del G is equal to V dP minus S dt. S dt. Therefore, if temperature is constant, dt is equal to 0, therefore S dt is equal to 0. Therefore, dg is equal to V dP. Therefore, dg by dP at constant temperature is equal to V. That means, if you observe this expression, finally this expression has become equal to V. Therefore, we can define the volume of the ideal gas in terms of the thermodynamic functions. So, in terms of the thermodynamic functions, volume means change in free energy with respect to change in pressure at constant temperature is equal to V. Next, similarly, if pressure is maintained constant, if pressure is constant, dP is equal to 0, therefore V dP is equal to 0. Therefore, dg is equal to minus S dt. Therefore, dg upon dt at constant pressure is equal to minus S. Therefore, if you observe this expression, if I bring the negative charge this side, dg by dt at constant pressure is equal to S. That means, now based on this expression we can define the absolute meaning of the entropy. Decrease of free energy with respect to temperature. Decrease of free energy with respect to temperature at constant pressure is equal to entropy. Next, Gibbs Helmholtz function. See, this expression G is equal to H minus Ts is called Gibbs function. Change in free energy is equal to change in enthalpy minus T ds. This is called Gibbs Helmholtz function. So, with the help of the Gibbs Helmholtz function, now we can predict the spontaneity of the reactions at constant temperature. Therefore, at a constant temperature, see, if the reaction wants to be spontaneous at constant temperature, if a reaction wants to be spontaneous, del G must be negative. Next, if reaction wants to be non-spontaneous, del G must be positive. Next, if any reaction wants to be at equilibrium position, if any reaction wants to be at equilibrium, then del G must be 0. That means based on the Gibbs-Helmholtz function, we can predict the spontaneity of the reaction. In order to predict the spontaneity of any reaction, first we have to calculate the change in free energy for that reaction. During the calculation of change in free energy, if we get the change in free energy with a negative sign, then we can say that reaction is spontaneous. Spontaneous means that reaction will naturally take place till the reach of equilibrium. Next, whenever if for any change, if we calculate the free energy change del G, if we get the result with a positive sign, then we can say that reaction is non-spontaneous. Non-spontaneous, that means that reaction will not take place on its own. However, we can conduct that reaction by supplying the energy from outside. Similarly, for a given reaction, if we calculate the free energy del G, if we calculate the free energy, if we get the 0, that means the reaction is already at equilibrium. The reaction neither proceeds in the forward direction nor proceeds in the backward direction.